Good morning, class. So, today in lesson 8, we're still solving equations, but we're solving equations with rational coefficients. So, remember, a coefficient is just the number that is in front of the variable, all right? And then rational refers to rational numbers. Remember that rational numbers are or include fractions and decimals, but more specifically, when we talk about rational numbers, remember it's fractions that when you simplify them, they either become a whole number or they become a decimal that terminates or repeats. Okay? So please make sure you remember that about rational anything. Okay? So number one, very simple and straight to the point. It says solve the equation 2/3 x minus 1/6 equals 5/4 x plus 8. Check your solution. So obviously the first thing you would notice about this equation is that it has a lot of fractions. And as your teacher already know, we don't like fractions, but we have to deal with it, right? So let's get to solving it. So if we look at the equation, I'll rewrite it so we got more space to work with. So if I'm gonna be quite honest, this is a lot to work with. It's a lot of fractions. So if I started working it out, right, of course we go through our steps. Is there a step one? No, because there's no parentheses. Is there a step two? No, because there are no like terms on either side. Okay, so I would automatically be at step three, but not regular step three, but the special step three, because I have two variables right now and I need to get rid of one. Okay, so if I was getting rid of one, like I told y'all before, you would want to get rid of the one that results in you having a positive variable after getting rid of it. So right now, 2/3 x and 5/4 x are both positive. So to get rid of either one of them, I would have to subtract, right? So if I subtract, so let's say I subtract 2/3 x, all right? So I subtract 2/3 x from both sides. In order to subtract fractions, I have to find a common denominator, right? So that means the common denominator of 5/4 and 2/3 would be 12. In order to get to 12 here, I would have to multiply by 3 to the top and the bottom. In order to get to 12 here, I would have to multiply by 4 to the top and the bottom. To change both of these fractions, this one would be 15 over 12. This one would be 8 over 12. Okay, so then remember I'm subtracting them, so there's a subtraction sign in between these. So 15 minus 8 would give me 7 over 12. So it looks like I made the correct decision of choosing to get rid of the 2/3 x versus the 5/4 x, because I'm pretty sure if I did it the opposite way, once again, I still would have had to find the common denominator, so I still would have been working with these two fractions, but instead of the 15 being first, it would have been second, which would have made this fraction negative. Okay, so now if we continue, that means this is now gone, right? I still have the negative 1/6 is equal to 7/12 x, still have the 8 plus 8. All right, so now I can really start getting rid of everything. So I would get rid of the plus 8 first by doing the minus 8, right? But once again, now I have to find a common denominator, right? So that's 1/6 and then 8 over 1 in order to subtract these, right? Oh yeah, don't forget this is negative. The common denominator would be 6 here, which is very simple. So this one will change into 48 over 6 minus 1/6, and this is negative. So negative 1, right, because it's a negative fraction, minus 48 would equal negative 49 over 6. I don't believe this fraction has a common denominator. Let me see real quick. Nope, I can't think of anything right now, so that means this would equal negative 49 over 6 is equal to 7/12 x. And then, of course, finally, in order to get rid of the 7/12 and get x by itself, there are two ways you can do this. One way could be easier than the other, depending on how you want to operate it. I'm going to do it the way that Mr. G usually does it, which would be multiply each side by 12 first, okay? I'm going to multiply by 12 over here. This is going to cancel out the denominator of 12 to give me 7x is equal to, then I have to pull out my calculator. Everybody should have a calculator on their desk. So do 12 times negative 49, which would equal 588 divided by 6. This is a negative fraction. So then we need to see if we can divide 588 by 6. See if we can simplify it. We can divide 588 by 6. So when we divide 588 by 6 to reduce the fraction, it gives us, actually, because we don't need to write this, since we can reduce it, it gives us 98. All right, and then finally you have to divide by 7. All right, and then x would equal, oh, and this is still negative, by the way. Don't forget your negatives. So then 98 divided by 7 is 14. So this is a negative 14. Okay. So as you can see, this is a very long, complicated process when you're dealing with fractions, but there is a method and a way to make this easier. Okay. So on a separate sheet of paper, because if you copy down everything that I did, your paper's probably filled up like mine was. I want you to write this method down, and since it's on a separate sheet of paper, that also means you can take this method with you as you do the rest of your problems. Okay. As you can hear, there's a train passing, but that's okay. That just means we're up early in the morning. All right. So let's talk about the easier way. So first, I have to remind you of a technique that I briefly went over, or not a technique, a property that we went over in class in the last lesson, in lesson 7. So we have two properties of equality, okay? We have the addition property of equality, and we have the multiplication property of equality. So I'm going to briefly talk about how they work, right? So if I take the expression, or the equivalent, if I take the equivalent, not equivalent, if I take the linear equation that we're working with, because remember, this is a linear expression, this is a linear expression, the whole thing is a linear equation. So if I take the linear equation, so according to our property of equality, right, equality, because we have two of them, according to either property, since this linear expression on this side is equal to this linear expression on this side, right? So basically, if I wanted to call this something simpler, I could say this is A. Whatever this equals on this side would be A. And then whatever it is on this side would be B, okay? So since according to the problem, A is equal to B, right? With the property of addition, if you add A to C, saying C is some random number, but also add B to C, so that means, so let's go over what we know already, right? We know that A and B are equal, so that means they're the same number. So if I add the same number to both of them, they should still be equal, okay? That is property of equality with addition, all right? Now let's talk about property of equality with multiplication. It's not that different, it's the same concept, all right? So once again, right, if I know that this is equal to, if I know, go back. If I know that this expression is equal to this expression, or A is equal to B, just like with addition, but now instead of talking about addition, we'll talk about multiplication. If I multiply, wrong thing. If I multiply A times C and multiply B times C, once again, I should get, or the equation should still be equal, okay? And the reason this works is because A and B were equal from the beginning. So basically, whatever's on this side was equal to whatever was on this side in the beginning, according to our equation. So if I add the same number to both sides, addition property of equality, it should stay equal. If I multiply the same thing on both sides, it should stay equal. Okay, that's multiplication property of equality. So now that we have established what the properties are, okay, let's use one of those properties in order to get us an easier method of solving these problems. Okay, I just need my eraser to cooperate. Okay, so now we have our equation, right? So I'm going to tell you, since our coefficient, which is the number next to the variables, right, are fractions, it's better to use the operation or the property of equality that deals with multiplication. Okay? Because the opposite of division is multiplication, and we know fractions are division. So when you use this property, you are multiplying the entire side of both equations by the same number, just like we just talked about, because that's how the property works, okay? You're not going to just choose some random number. The way you decide on the number that you choose to multiply the entire side by is you look at the denominator of each fraction and you try to find the greatest common factor between all of the numbers. So we have three fractions. We need to find the greatest common factor of all three of these fractions. Or basically a number, I said the greatest common factor. We need to find the greatest product, honestly, that they all can become. So take that back. We need to find the greatest product. Okay, so I know that 3 and 6 could have used 6 and had 6 in common, because 3 times 2 is 6 and 6 times 1 is 6, but 4 cannot use 6. All right, so if I'm looking at these numbers, most likely I can use 12, because I know that 3 times 4 is 12, 6 times 2 is 12, and 4 times 3 is 12. So I will multiply both sides by 12. Okay? So that means I'm distributing now 12 to all of the equation. The reason I'm doing this is because when I distribute 12 to all of the equation, it should give me all whole numbers when I do this math, okay? So, of course, we have to do 12 over 1 to do the math with the fractions. So if we do the first equation here, that would end up being 24 over 3. We know that 24 divided by 3 is 8. So this would be 8x for the first one. Then if we do the second one, that would be negative 12 over 6. We know that 12 divided by 6 is 2, so this would turn to negative 2. Okay, equals, on this side, we would do 12 times 5, which is 60. 1 times 4, which is 4. We know that 60 divided by 4 is 15. So that's 15x. And then on the last one, we would do 12 times 8, which is 96. Which is 96. And then that'd be over 1. 96 over 1 would be equal to 96. So that'd be plus 96. Okay? So now my entire expression, it should still be equal because I multiplied it by the same number, and now I have all whole numbers. So my system or my process should be a lot easier now. Okay, but before I proceed, I'm going to go back over what I did, right? So in the very beginning, when you get an equation, the equations are supposed to be equal to each other. So one side is equal to the other. Since this is a true statement, that allows you, when you're solving it, to use the property of the multiplication property of equality, which means you can multiply both sides by the same number and they should still stay equal. Since we had our fractions, we're trying to get the fractions to go away, so we had to find a common product of all of these numbers. The common product of all these numbers is 12. They all have 12 in common. Okay, so we multiplied everything times 12. All right. And when we multiplied everything times 12, we got different fractions that when we reduced them, turned them into whole numbers. Okay. And now our equation has all whole numbers in it, which is easier to solve. So remember, I solved this earlier, and the answer was negative 14. But let's see if we get the same answer, okay? So once again, we're automatically at special step 3, which means we have to get rid of one of the variables. We should get rid of the 8 because if we got rid of the 15, that would be 8 minus 15, which would have gave us a negative 7 versus 15 minus 8, which gives us a positive 7x. All right, this comes down. This also comes down. Equal sign stays in the middle. So now I have to get rid of the 96, so that's minus 96 on both sides, right? Negative 2 minus 96, that's a negative minus something, so that makes the negative bigger. So this would be negative 98 is equal to 7x. And then, of course, the last step should look familiar to what you already have on your paper. Divide negative 98 by 7, and x equals, once again, negative 14. So all of the extra work I did the first time, I cut a lot of it out by using my multiplication property of equality. So when you have fractions, you should try to see if you can find a common product between them to multiply that number or those numbers by. And of course, don't forget to check our work to make sure negative 14 is correct. You would plug in negative 14 for x in the original equation that we solved up here. Okay, and so you would, well, actually, you could plug it in for x right here too, because technically, since the equation is still equal, we could plug it in for either one because it's still set up where they're equal to each other. So we should just use the one that has whole numbers to make it a lot easier for us to make sure that they're still equal. So that would be 8 times negative 14 minus 2 equals 15 times negative 14 plus, okay, I can't write the rest, but plus 96. So if we use our calculations or our calculator, 8 times negative 14 would be negative 112 minus 2, which is equal to 15 times negative 14, which will give me 200, a negative 210 plus 96. All right, so now we know that negative 112 minus 2 would be negative 114, which is equal to, if we do negative 210 plus 96, remember we would have to actually subtract these numbers and then take the value of the highest number. So if we do that, that would be once again 114, but the negative was more, so they're equal. Okay, so we know that this process works. All right, so now let's go to number 2. All right, so number 2 also has fractions in it. So I'll kind of walk us through the beginning, but I'm going to have a point coming up that I want you to pause the video and see if y'all can figure it out, all right? So if we go through it, right, so let's all start off together. So we got 29 minus 1/3 h equals h plus 5/3. All right, so do we need to do step 1? No, there's no parentheses. Do we need to do step 2? No, there are no common terms or like terms on either side. So now we're on special step 3. But before we complete special step 3, we can try to get rid of some of these I'm talking about fractions. Okay, so I want you to pause the video here to see if you guys can figure out the common product of this whole expression. So go ahead, someone get up, pause the video now, and take about 2 minutes to figure that out. See if you can figure it out. Okay, so this one should have been pretty easy. So if you didn't notice, whenever you have fractions that have the same denominator, the common factor or the common product would be the denominator. So you would multiply both sides by 3. Okay, so once again, this means we're distributing 3 to both of these. So that would be 29 times 3, which equals 87. And then remember, all that multiplying this fraction by 3 does is basically cancel out the denominator. So that means this becomes a negative 1h, but I don't have to write negative 1h. I can just write negative h because I know that h represents 1. Then on the other side, 3 times h would be 3h. And same thing happens to the denominator here. It cancels out because I'm multiplying it times 3. And so that would be plus 5. Okay. If you're confused to what I mean when I say they cancel out, I'll show you real quick. So if I did 3, right, times 1/3, 3 times 3 is 3, 3 times 3 is 3, which is why it became 1. It's negative 1. On the other side, 5 over 3 times 3 over 1. 3 times 5 is 15. 3 times 1 is 3. This would equal 5. So it basically just canceled out the denominator. Okay. Whenever you multiply a fraction times its denominator, you cancel it out. All right. That's with any fraction. All right. So continuing with the problem, now we can actually do real step 3. So we would get rid of one of the variables first. It's better to get rid of this negative h because to get rid of it, we have to add. And remember, we want to keep things positive. So that'd be a plus h on both sides. This goes away. We still have a positive 87 over here. Equal sign stays in the middle. 4h. Bring down this plus 5. Now we can get rid of the plus 5 because we're trying to get the variable by itself. All right. To get rid of plus 5, you do minus 5. This goes away. This would equal 82 equal to 4h. Divide by 4 to separate h and 4. This will turn into 1. So h would be equal to let me see. 82 divided by 4. It would be 20.5. So in this situation, we can use the decimal, okay, because it does not repeat. It terminates and it's short. So I'm okay with the decimal, but you could have also used, the fraction 82 over 4. But if you used the fraction 82 over 4, you would have had to reduce it. If we reduced it, we would have to reduce it by 2 because they have 2 in common. So you could either use 82 over 4 or you could have used, that would be 41 over 2. Okay, so h could equal this, or this. Okay. Remember, I'm only okay with this decimal because it terminates and it's not that long. If it was a longer decimal, we would have used the fractions. Okay. So now we have to check our work. So since we can put it in the original equation that we ended up turning it to. Okay. Since we were already at step 3 and everything should have stayed the same, so that would be 87 minus 20.5 is equal to 3 times 20.5 plus 5. All right, so PIMDADs, we would do 3 times 20.5 first, which would give us 61.5 plus 5 is equal to 87 minus 20.5. All right, 87 minus 20.5 would equal 66.5. And then 61.5 plus 5 would equal 66.5. So we know our answer is correct. Okay. So now let's move on to number 3. All right. So for number 3 is a bit different because now instead of having fractions in there, we have decimals. Okay. So I know some of y'all will be like, well, I could solve it with decimals, but there's also a way where we can make the decimals whole numbers, okay? And we could deal with just whole numbers with the decimals. So real quick, I'll give you a quick tutorial. Whenever you have a decimal number, right? So let's say I have, or let me say it like this. Every number has a decimal. So 21, 5.4, 2.5, right? In order to move the decimal, in order to move the decimal to the right, which would make the number bigger, you have to multiply times 10. In order to move the decimal to the left, or to make the number smaller, you would divide by 10. The reason dividing by 10 or moves the decimal to the left is because the number is becoming smaller. The reason multiplying by 10 moves the decimal to the right is because the number is becoming bigger. So if I was to multiply this by 10, the decimal originally was right here, right? Because 21 is a whole number. So let me actually do it over here. So 21 was a whole number. It moves over 1. So if y'all did the math regularly, y'all know 21 times 10 is 210. But moving the decimal, you see I fill in the blank with a 0, and I still get the same answer. So same thing here. I multiply times 10, I move it over, and now it's 54. Multiply times 10, I move it over, and now it's 25. Okay? So we take that same concept with what we're doing right now, right? So if we look at number 3, you go to step 1. We don't have step 1 to do. You go to step 2. There's no step 2 to do. So we're on step 3. We're on special step 3. But before we do that, we could change all of the decimals into whole numbers. Since they all have one place to move to make them whole numbers, we could just multiply each side by 10, okay, to do what you just seen me do. So if I multiply each side by 10, that distributes, right? That distributes. So this number would become, move the decimal place one place, 72. Plus this number will become 48R is equal to 36R minus 12. So now once again I have whole numbers. So now it's a lot easier for me to solve my equation. So now that we're here, actually, I want you to pause the video here, and I want you to finish solving the equation to see what you get for R. So someone get up, pause the video. I'm going to give you like 2 to 3 minutes to finish solving the equation. Go. All right, so we should have gotten rid of the 36R first, because if you got rid of the 48, you would have ended up with a negative variable. And remember, we don't want negative variables. 48 minus 36 is 12R. You still have the 72, that's plus, equals, you still have the negative 12. All right, then you have to minus 72 from both sides. Okay, so this one cancels out, and then you have 12R is equal to negative 12 minus 72. So that's two negatives being put together, basically. So you're adding them. So that would equal 84, negative 84. Then divide both sides by 12 to separate the variable from 12 to say that R equals negative 7. Okay, so now we can check our answer by using the equation we had right here, which was 72 plus 48R equals 36R minus 12, but we're going to sub in negative 7 for R, so that'd be 72 plus 48 times negative 7 equals 36 times negative 7 minus 12. So once again, we do all have calculators on our desk. That would be do PEMDAS. So 48 times the negative 7 would give you a minus, because it's negative now, 336. 72 still in the front. 36 times negative 7 would give you 252 minus 12. All right, so then 72 minus 336. So you did not have enough, so your number's going to go into the negative. So that would be negative 264. Okay, and then 200 and, oh, I'm sorry. This 252 should be negative because it's negative 7. I'm sorry, I didn't include that. Negative 252 minus 12, so it's two negatives being taken away from each other. So that would basically be putting them together would equal the same thing, negative 264. All right, so we proved that R should be -7. All right, so number 4 has fractions again. So I want you to go ahead and try to do that on your own. So pause the video real quickly, and I'll give you like 5 minutes to figure that one out. So someone get up, pause the video real quick now. Okay, so now that we have done that problem, what y'all should have did first was, of course, go through your steps. So step 1, parentheses. Is there parentheses? Yes, there is. So you most likely distributed this 1/6, right, to get 1/6W plus you will multiply this to get 18/6, which can reduce to +3, equals 2 minus 3 seconds W. All right. Then we go to step 2. Are there like terms on this side? No. Are there like terms on this side? No. So then now we're at step 3, but we're at special step 3. But we don't want to use the fractions, so we need to turn the fractions into whole numbers by trying to find the greatest product that they have. You should have figured out that they have a greater product of 6, because 6 times 1 is 6 and 2 times 3 is 6. So now we multiply each thing times 6. So remember, here it's just going to cancel out the denominator. So that means it would be 1W, or just W. 6 times 3 is 18, so that's plus 18, equals 6 times 2 is 12. And then over here, you have to turn into a fraction. So 6 times 3 would be 18/2 negative. So this would be a -9W. All right. So now we have whole numbers, so we can solve our equation. So the best thing to get rid of in our special step 3 would be the -9, because anytime we're getting rid of a minus, we're going to automatically end up going to a positive because we have to add. So then that would be 10W, bring down the plus 18, equals bring down the 12. So then we got to get rid of the plus 18, so that would be -18. -18. Okay, this goes away. It's 10W because that's still there. Equals 12 minus 18 is a -6. Then you divide by 10 on both sides. So that means W is equal to -6/10. But of course, I want you to reduce this fraction. And when you reduce this fraction, you should get -3/5, because you divided the top and the bottom by 2. Okay. You can plug this back in to check your work. If you plug it back in to check your work, you should see that -3/5 works for both problems. Okay. All right, so if we continue to the next page, we can also use this method to help us solve geometrical figures, right? So it says, consider parallelogram WXYZ. So there's a couple things we need to talk about a parallelogram real quick, just in case some people don't remember. Okay, so first of all, a parallelogram is called a parallelogram because it's made up of 2 pairs of parallel lines. So this line and this line are parallel to each other, just like the top and the bottom are parallel to each other, okay? A parallelogram can be compared to a rectangle because this length should be the same as this length, and this length should be the same as this length, okay? So opposite sides basically match on a parallelogram, just like opposite sides match on a rectangle. Okay, so let's read the problem. The problem says, what is the measure of angle WZY? So remember, when we're looking for an angle, we need 3 points. So that would be W from Z to Y. So this expression is what they have for us for WZY. So now, if we look across or opposite of WZY, we have another angle, which is WXY. What type of angle relationship does WZY and WXY have? Think about it. They're opposite of each other. If you're saying vertical angle relationship, you are correct, which means that these two expressions or these two angles should be equal to each other. So that is how we would solve or find out the measurement of angle WZY. All right. So let's put our equation together. So that would be 2/3 A minus 8 is equal to 1/6A plus 37. Okay, so we don't have parentheses, right? So we can skip step 1. We don't have like terms on either side, so we can skip step 2. We're at special step 3, but I don't want to work with these fractions. I want to work with whole numbers. Okay, so to make them whole numbers, I have to try to find a common product between 3 and 6. I know that 6 times 1 is 6. I know that 3 times 2 is 6. So I can multiply both of them by 6. And it should give me whole numbers from both results. Okay, so on this side, you'll be doing 6 times 2 at the top, which is 12. 3 at the bottom. 12 divided by 3 is 4, so that's 4A. 6 times 8 is 48, so that's negative 48 equals, on this side, remember the 6 makes the 6 at the bottom cancel, so that's just going to have A by itself because it would be 1A. And then 6 times 37 is 222. All right, so now we have our expression. Now we can finish solving it. So we got to get rid of one of the A's first because we're still on special step 3. We would get rid of the A by itself, so that'd be minus A gets away. That's 3A minus 48 is equal to 222. Then we would add 48 because we got to get rid of that, which would equal 3A. It's equal to 0 carry the 1, 270. And then divide by 3 to say that A equals 270 divided by 3 should be 90. Okay, equals 90. Okay. So now that we know what A is, to actually answer the question, we would have to plug A into this expression. We don't have to put it back in the original equation because that would be solving both. We know that these angles are equal, so I only really need to plug it into one. Okay. So that would be 2/3 times 90. I'm going to go ahead and put it as a fraction already. Minus 8. So we do the top, that would be 180. The bottom divided by 3 minus 8. So 180 divided by 3 is 60. 60 minus 8 equals 52. So that means the angle measurement of WZY is 52. Okay, so now I want you guys to try to do part B. Part B says, what is the length? Okay, remember length is on the outside of a shape of WX. Remember what I told you in the beginning when I talked about the parallelogram, that opposite sides are the same length. You really only have 2 expressions left to use. All right, so see if you can figure out the answer. I want the whole answer to part B. Go ahead, pause the video. All right, so we should have tried to figure out the answer to part B. Okay. So first of all, we have to establish what we're looking at. So the length WX is at the top of the figure, and we will use the length at the bottom to measure or to determine what the length of ZY with WX is. So we would set them up where they're equal to each other. Okay. So that would look like us doing, well, actually, I gotta see. That's 3 over 2C minus, so 3 over 2C minus, I think 18, right, is equal to 1/4 C plus 7. So it's equal to 1/4 C plus 7. Of course, we go through our steps as we usually do. We do not skip this until we know what we're looking at. So if we go through our steps, step 1, we don't have to do, there's no parentheses. Step 2, we don't have to do, there is no like terms on either side. Of course, we're on step 3, but we've been dealing with special step 3 this whole time, so we're on special step 3 again. But before we do special step 3, I want to get rid of the fractions because I know whole numbers are easier to work with than fractions. So that means I have to use the multiplication property of equality because that's what we've been using all lesson. Remember that. To find a common product between the 2 and the 4 because we only use the denominators when we're doing fractions. All right, the common factor or product here would be 4 because 4 times 1 is 4. 2 times 2 is 4. So then if we multiply these, right, we know that 4 times 3 would be 12. 1 times 2 would be 2. So that means this will turn into 6C. 4 times 18. So let's see. Oh, clear. 18 times 4 would be, so that's a negative 72 equals, we know that this 4 is going to cancel this 4 out because remember, like I told you, when you multiply a fraction times its denominator, it just cancels out the denominator. All right, so this would be just C because that would equal 1C. 4 times 7 is 28, so that's a plus 28. Now we can actually solve this problem. So then we would, let me scroll up so that y'all have more space. Then we would get rid of one of the C's because we could actually do special step C now. It'd be easier to get rid of just the 1C or the C by itself because we'll stay in the positive. This goes away. This will equal 5C minus 72 equals plus 28, or just 28. You don't have to put the plus. Then we would get rid of the 72, so that would be plus 72, plus 72. This goes away, bring down 5C. 28 plus 72, 0 carry the 1 is 100. Divide by 5. You should get C is equal to 20. So in order to get the actual answer, which is the length of line WX, we would have to plug this into, I think it's this expression, the first expression. Let me make sure. Yep, we would have to plug it into that expression. We don't have to plug it into both because they are equal. Please remember that. So if we plug it in and get our answer, that would be 3 over 2 times 20 over 1, right? Minus 18. Multiply top, you get 60. Multiply bottom, you get 2. 60 divided by 2 minus 18. 60 divided by 2 is 30. 30 minus 18 is what? 12? Is 12. So the length of WX should have been 12. Please do not be afraid to refer to this video again if you need help. Your homework, okay, very important, or your classwork to do after you finish the video is go to page 143 through 147. Okay, you guys are doing numbers 1, 2, 4, 5, 8, and 9. I would like you to do them by yourself first before you try to talk with your group or with a partner, so you can see if you understand how to do this on your own. Okay, so you see it right here. You can pause the video right here. That way we all remember what the numbers are and where the pages is. Have a nice day.